Hey guys, we're here for our next session. We have Allison, a co-founder of UMA. She will be doing a talk around how to build synthetic tokens without an on-chain price feed, and I'll let her take it from here. Can you guys confirm that you can hear her?
Hi everyone, my name is Allison Liu. I'm the co-founder of UMA, and I'm really excited to be here. This is actually my first virtual conference, and I'm really impressed at Shinji's organization and all of this. As she mentioned, I'm going to be talking to you about priceless synthetic tokens today, but for a little bit of background and context around kind of our position in that space, we are a blockchain-based startup that builds financial infrastructure for Ethereum. Specifically, this means two things. We are building an on-chain decentralized Oracle service, as well as smart contract designs that people can use to create all kinds of different financial products on the blockchain, starting with synthetic tokens. So without further ado, I'm going to go ahead and start sharing my screen so you can see the presentation. Okay, great. And Shinju, just let me know if I encounter any tech problems during this. So before I dive into the actual demo of how you yourself can go through and create synthetic tokens that don't require an on-chain price feed, I'm just going to provide a little bit of background context for the motivation of the problem that we're really trying to solve here. So I'm going to describe kind of the Oracle problem for DeFi at large, as well as UMA's proposed solution, which is priceless contracts, Oracle minimized designs. And then we'll go into a quick demo of how you can actually interact with these tokens. So the motivation for what we do is, for any of you that are paying attention to DeFi, you've probably noticed that most DeFi smart contracts depend on price feeds. So for example, if you are looking at like Compound or Maker, these collateralized lending protocols, they all depend on a price feed, a price that gets pushed to the blockchain to determine whether somebody's position is correctly collateralized or incorrectly collateralized. And obviously, everybody cares about UX, and digital assets are extremely volatile. So these price feeds need to be really fast in order to be performant. But this kind of creates a problem because, as we all know, smart contracts are actually not that smart about the real world. Smart contracts have no sense of what the price of ETH is. And so, for example, if you've deposited ETH into some DeFi smart contract and borrowed DAI against it, well, one bad price for ETH, one price that says that the price of ETH is $10, and you may get liquidated unfairly. And this has actually happened in DeFi before with some of the different protocols or platforms. And this is true as well for any sort of trading platform that depends on an Oracle price to determine the trade price as well. So overall, oracles are a huge point of weakness for DeFi. We all care a lot about security and safety, and we talk a bit about self-custody as being a really important factor for the safety of using a particular platform. But the reality is that even if you own your private keys, whoever controls the oracle on your smart contract is actually the person that can determine whether or not you are able to eventually get your money back. And so the way that we kind of think about oracles is that we actually don't believe that there is such a thing as a perfect, incorruptible oracle. We believe that anytime there's money inside of a smart contract and the payout of that money depends on some oracle price, that there is some potential that something can go wrong. It could be malicious, like a bribe, or it could be, just downtime and a flash crash. The way that we kind of define a honest oracle, though, is we look at how much money is inside of a smart contract and how much could potentially be gained by a malicious attacker if they were able to corrupt the oracle. And we call that profit from corruption. We also look at how much money it would potentially cost to corrupt some external reference price. And we consider that to be the cost of corruption. So our goal here at UMA is to design a decentralized Oracle service where the cost of corruption is greater than the potential profit from corruption. And that's kind of what we call an honest Oracle with economic guarantees. So you weren't here, though, to just talk about oracles. You were here to talk about how to use oracles in a priceless way. And this is the motivating factor behind why we pound the table about our priceless philosophy. We really think that minimizing oracle usage is the right way to use oracles in a blockchain environment. The first reason is simply that it's more efficient. So going back to kind of a collateralized lending example, historically, DeFi smart contracts have required a price feed to tell the blockchain whether somebody's position is correctly collateralized or not. But that's actually really inefficient. Anybody can observe the positions on the blockchain and do their own off-chain computations around whether the collateral is sufficient or not. And what we can actually do instead is optimistically assume that everybody is correctly collateralized. And there's no need to push a price on chain so long as that is true. But what you do need price feeds for, of course, are to perform liquidations, to make sure that if I'm depositing collateral into a contract, that I'm not going to be able to get liquidated unfairly. Well, here, priceless contracts can actually be more performant. So the idea would be that if you've deposited collateral into a smart contract, and let's say you've deposited ETH to borrow DAI, and the price of ETH goes down. Again, all this stuff can be happening, like all the observations can be happening off-chain. The moment that the off-chain price for ETH has declined, somebody could kick off a liquidation transaction. In the old paradigm of the way that oracles are used in DeFi right now, you'd have to wait for the oracle price to update, which means that during that period of time, that oracle transaction is competing with every other transaction that's trying to go onto the blockchain. And most oracles are obviously not updating constantly. Even the most performant ones are only updating every few minutes or so. So what we can do with priceless contracts instead is to say, well, anybody can observe what's happening off-chain. Anybody can look at the information and determine that perhaps somebody deserves to be liquidated, and perform that liquidation instantaneously. What you have to do to make it safe is simply allow that liquidation to be disputable for a brief period of time. And then only if there's a dispute do you actually then need to resolve to the DVM. And then once you resolve, sorry, the DVM is the name for UMA's on-chain oracle. Once you resolve to UMA's DVM during the course of a dispute, the conversation about what price to actually resolve to is asynchronous and ultimately results in pulling in a historical price to resolve the outcome of that dispute. And that feature actually ends up making this smart contract more resilient. Because if you think about how oracles are used right now, people are just pumping in prices instantaneously and using them inside of a smart contract immediately. But the problem is that if there is a problem, like when oracle failures occur, typically those oracle failures are going to be very live and very brief. You do not want to be using that oracle price in that moment. Instead, by using a dispute mechanism and allowing the DVM the time it needs to resolve to a historical price, we can be more confident about the accuracy of that historical price. One example here is Coinbase's API is a very cool, useful tool for DeFi. But if you guys recall last year, Coinbase had a flash crash where Coinbase was the only exchange where I think the price of ETH went down to about $13. And so even if you were using Coinbase's API at that point in time to correctly collateralize your smart contract, you would have been in trouble. You may have seen all of your contracts get liquidated when really it was the Coinbase price that was out of line with every other exchange and broader market consensus. What's cool here is that, obviously after the fact, Coinbase resolved this issue and made traders whole on their platform. And the UMA DVM system would have done the same, where if a contract got liquidated during that period of time, due to some sort of outage or weirdness or volatility in the marketplace, after the dust has settled, the DVM can ultimately go back in time and provide a price that is actually more accurate and better reflects broad market consensus. So the way that, kind of all these systems fit together is you have a synthetic token contract, and the synthetic token contract basically pays fees, we call them taxes, so that they can use our decentralized Oracle service, the DVM, later on. This tax revenue is later used to buy and burn UMA tokens. And the reason why this is necessary is because UMA token holders are the ones that vote to resolve price requests and resolve token contract disputes. Okay, so without further ado, I'm going to go ahead and demo a command line tool that you can use to interface with the UMA system. There's two things that I think you guys might be interested in learning how to do. One is if you own the UMA token, I'm going to show you how you can use this command line tool to vote on price requests, basically vote to resolve people's disputes. And then the second thing I'm going to show you how to do is how to open a new token sponsor position to create a new synthetic token. Okay, so I've already kind of set it up here. Well, you guys can see my screen. But what I did is I pre-deployed from the UMA Synthetic Token Factory a token contract that defines synthetic Bitcoin tokens. And then we're going to go through a sponsor flow of creating new priceless synthetic tokens. So first thing you do is look at the live markets. So here, the only live market that I've deployed for purposes of this demo is a Bitcoin dollar market. I don't have a position, so I'm going to open up a new one. And we'll just choose some number, 10 synthetic Bitcoin tokens to create. Cool. So this is a menu-based tool. It's done 3 transactions so far. It has taken ETH from my wallet and wrapped it into WETH so that it's an ERC20, and then deposited that WETH into the synthetic Bitcoin, the priceless synthetic Bitcoin contract, and then minted synthetic Bitcoin tokens. So you can see that now I have 10 synthetic Bitcoin tokens, and I've deposited a total of 15 ETH. So once I have this position, what's actually happened is by owning tokens, I am long synthetic Bitcoin, but by having minted tokens, I'm short synthetic Bitcoin. And net, I have no risk at the moment. In order to actually get short risk, you'd have to take your synthetic Bitcoin tokens and sell them to somebody else in order to get short synthetic Bitcoin versus ETH. Okay, so going back to position management, there's a number of actions that you can take after you've created a synthetic token position. The first thing is you could simply mint more tokens and by depositing more collateral. So it's the same flow as before. The second thing you could do is manage your collateral. So you can either deposit more collateral, which is pretty self-explanatory. We'll just add one more ETH. Cool. So you can see that the total amount of collateral I've deposited has increased. You can also withdraw collateral. And here's where pricelessness differs a lot from normal DeFi contracts. In a normal DeFi contract, if you've deposited collateral and minted tokens, you can manage your collateral positions freely as long as you're not violating the rules of the contract versus the on-chain Oracle price. Pricelessness is different. There is no on-chain Oracle price, right? And so the contract is always optimistically assuming that everybody is correctly collateralized. Now, obviously, if I go and I withdraw collateral from my position, I may become under-collateralized. So what we do to ensure the safety of everybody's position is, let's say I went and I tried to withdraw 10 ETH from my position. What would actually happen is I don't get to withdraw it immediately. I would simply enqueue a request to withdraw collateral. So I had previously deposited a bunch of ETH to mint synthetic tokens. I want to withdraw collateral. It's my responsibility to make sure that even after withdrawing collateral, that I'm still correctly collateralized. But if I'm wrong, if the price of ETH drops, or if I'm just being malicious in some way, there's a liveness window before the withdrawal request can be approved. During that liveness window, other people scanning the blockchain and observing what's happening can actually liquidate me. And so that's kind of my risk here, that if I get liquidated because I've tried to withdraw too much money, or too much collateral, then I would have to pay the liquidation penalty. If, however, it's fine for me to withdraw all the collateral, then after this brief waiting period is over, my transaction, my withdrawal goes ahead and processes, and I get my ETH back out into my wallet. And so once you've made this withdrawal request, you basically just have to wait for the hour to pass, or I'm going to go ahead and cancel it here so that we can go into other things. Cool. The final thing that I'm going to go over for purposes of this demo is redeeming tokens. So remember, we deposited collateral here, and then we minted some synthetic tokens. Potentially, if I want to unwind the position, all I have to do is repay the tokens that I've minted. So when I repay tokens, what happens is I basically pay in synthetic tokens, and then I get a pro rata amount of my collateral back. So if I have 11 tokens outstanding and I want to repay one, then I'm going to get my pro rata percentage back out. And that's actually all automatic because there's no net risk transfer there. I'm basically just reducing the total open interest in this synthetic token product. Cool. That was a really, really brief overview. I know we have a ton of documentation up on our website at docs.umaproject.org. You can basically, deploy your own custom synthetic token to your own local blockchain and play with this tool, play with understanding what the financial risk of this would allow you to create. Previously, we talked a lot about letting people create their own custom synthetic tokens. I imagine most of you in the audience in the future may just be future synthetic token holders or future synthetic token sponsors rather than creating some sort of a custom token. And so that's why I'm going through this demo in such detail. People always ask, of course, when mainnet. So right now we're in the process of getting community input on this priceless synthetic token contract factory, as well as wrapping up our Open Zeppelin audit. Once we've actually gathered the community input around how this contract works and wrapped up our audit, we're going to be going ahead and registering it with the DVM so that any of you can use it to create synthetic tokens on mainnet. And I'm going to be, I suspect that if all goes well, I'll be able to make a really exciting announcement at Ethereal next week. The second thing that I'm going to go over here in the command line tool is voting. So remember, we talked earlier that the way that the system works is priceless synthetic contracts require a on-chain price during a dispute. The way that these disputes are resolved is through an UMA token holder vote. So if you own UMA tokens, you'd have an opportunity to participate in resolving these types of disputes. Unfortunately, I didn't have time to actually enqueue a fake price request, so I'm only going to be able to share the actions that you can do. But the idea of this is every voting round has a commit phase and a reveal phase. The reason why there's a commit reveal phase is to prevent collusion or copy voting or anything like that. Since this is a Schelling point oracle, the intention is to derive the resolution through truly decentralized and Schelling point incentivized games. So there's really just two actions that you can do. You can commit your vote, which is to say you can provide the price that you think is correct to resolve the price that's been requested. Or if you've already committed your vote, you can reveal your vote. Each of these commit reveal cycles are 24 hours, and you just have to come here and sign with your key to commit and reveal your vote. And then the votes are tallied on chain through a stake weighted mechanism where the modal majority is considered to be the honest price and ultimately used to to resolve the priceless synthetic token contract. It's a lot of work, let's be frank. If truly decentralized things are a lot of work, and they are frankly less efficient in, well, not less efficient, but they're just more cumbersome than directly using an API oracle. So to incentivize people to actually participate in resolving price requests, there's rewards that are available during every voting cycle. Basically, if you participate in a vote and you vote correctly, the protocol generates inflation that you are able to retrieve if you also voted correctly. If you don't vote, or if you don't vote correctly, then you don't receive this inflation. So what this means is that if you're an UMA holder, you have a really strong incentive to participate in votes and to participate honestly. If you don't do that, then your stake basically eventually gets diluted down to zero. And that's how we incentivize both honesty during voting as well as participation for voting. So with all that said, I'm going to go ahead and stop sharing my screen and open it up a bit for questions here. I know a lot of this priceless contract stuff is really new, but we really believe that this is the right way to create scalable, secure synthetic assets on the blockchain that uses the blockchain's inherent security and settlement characteristics for it. And so I'd love to just get started and answer some of your questions. Okay. So the first question that I'm going to answer is Fred asked, what price are people using to determine if a position should be liquidated? And that's a really good question. So if you have an on-chain oracle, then you already have consensus. That's the price that everybody is going to use, and that's the only price that the smart contract will execute against. In this case, however, everybody is acting optimistically. And so let's take something really simple like the price of ETH dollar, right? Should we be using the price from Coinbase, or should we be using some sort of median of 5 exchanges, or should we be using a TWAP? Should we be using all 50 exchanges? Should we be using only fiat pairs or stablecoin pairs? Like, there's a lot of questions about what the right price index is, right? And so the way that that gets resolved is also through UMA token holder governance. In order for an UMA token holder to actually be able to accurately resolve a price request, and in order for priceless contract users to actually know what risk they have, they obviously need to know how the price is actually going to get calculated. And so there's basically a governance approval process to register every new identifier that people want to use. So anybody can basically propose a new identifier, and then UMA holders vote to decide whether they are willing to support it or not. And also in the proposal is the definition of how it's calculated. So, for example, right now there is an open UMA improvement proposal. That's what we call them, UMIPs. There's an open UMA improvement proposal to get the price of ETH BTC through a medianized calculation of 3 centralized exchanges: Coinbase, Binance, and Bitstamp, to a 60-second granularity and 4 decimal place precision. So, all that stuff kind of needs to get defined in advance, but leave the tiny little bit of room for social consensus in case some of these, or for governance, in case some of these prices become out of line with broad market consensus. So what we've built as a tool to kind of help people manage their positions is, in all of our tooling, there is a price feed library that you can plug into, that plugs into open APIs to figure out what the price is under good times. It doesn't get pushed to the blockchain. It just gets pushed. It's just a reference tool for you to figure out your own position's collateralization. And then the definitive price, in case there's a dispute, resolves to the DVM. The second question came from James. If transactions are disputable, doesn't that increase trading risk, as there will always be a possibility that one leg of your trading strategy gets reversed, leading to losses? Yeah, this is a really good question. So if so we can kind of walk through this as an example. So if I am a token sponsor, so I've deposited collateral and minted synthetic tokens and then sold those synthetic tokens somewhere, so I have some financial risk. And somebody liquidates me, but that liquidation was actually unfair, like they shouldn't have liquidated me, then assuming that the system is actually working correctly, where the unfair liquidation gets disputed, then the result of that dispute would show that the liquidation was unfair. And during in an unfair liquidation, the liquidator actually pays a penalty to both the disputer to incentivize them to perform that work, and the original token sponsor to incentivize them for having lost their risk. So the level and the parameterization of that sponsor reward needs to be proportional to how much it would potentially cost them to replace that risk, or the loss of financial risk during that period of time. Separately, for liquidators, if I'm performing all this work for the system and I'm going around liquidating under collateralized positions, then there's always this hanging risk that somebody might dispute me, right? And so the same thing again applies, where if I perform all this work and I'm doing the right thing, I'm performing liquidations correctly, but somebody disputes me and they actually turn out to be wrong according to the DVM, then I get to earn a reward from them as well. So then I not only get to earn my liquidation reward, but I also get to earn an extra dispute reward to compensate me for the lost time of having to go through this dispute process. So all of this stuff is trying to maximize our use of economic incentives as much as possible to reduce the total amount of actual transactions and to reduce the reliance of oracles on the blockchain. Okay, so somebody was asking about how we compare to, oh gosh, it looks like this might be the last question. Somebody was asking how our synthetic tokens compare to what Synthetics does. And we get that question a lot since we kind of both deal in synthetic asset space. So I think that the synthetic tokens that are created by the SNX platform are super interesting and useful. If you're somebody that just wants to trade from dollar to gold to Bitcoin to Tezos to whatever, you can do so on Synthetics Exchange really, really quickly with like a lovely UX. But that being said, the mechanics of the financial engineering of their tokens are really, really different from the priceless tokens that we're proposing. So the first one is that the underlying collateral in a Synthetics token is SNX itself, whereas the underlying collateral in UMA synthetic tokens are kind of ETH or maybe potentially DAI, whatever it is that the system kind of votes in. So that actually that creates a very different type of financial risk. The second thing is that Synthetics has this really great benefit of being able to trade peer to contract, meaning if a user wants to mint synthetic tokens, synthetic dollar, and then shift to gold, they can do that immediately, and that's a great UX feature. But what it does is it puts the burden on the pool of SNX stakers to take the other side of any arbitrary trade that anybody ever wants to do. So imagine you take the way that it works is imagine you take some pot of money and you stick it there and you say, okay, cool, there's a pot of money here and anybody can trade against this pot of money, whatever asset you want to trade that's available in the SNX system, you can trade against this pot of money and I will take the other side of every trade. That makes a great UX for the people that are doing the trading, but it creates a lot of financial risk for the people that have put the pot of money there. In the priceless synthetic token system, all of the financial risk positions are one-to-one. So for everyone who wants to be long gold, there's somebody who's short gold and is aware that they're short gold and has that financial risk. And so it kind of, it is definitely, it has its trade-offs. It's going to be a little bit harder to find the immediate liquidity versus the SNX platform, but it is going to be more financially resilient for all the parties involved. And Shinju, let me know if I can take one more or if we need to move on to the next
I think we probably need to move on to our next session. Thank you so much for the really great talk. Learned a lot.
Yeah, I'm sorry I couldn't get to all the questions. Thank you guys for the active participation. And my DMs on Twitter are open, or you can catch me in our dev Slack or email us. Really happy to engage with all of you. Just one plug. We have a request for comments out right now. We want community input on how to incentivize early developers and users in our ecosystem. And we would really, really love to get all of your feedback on that. So it's on my Twitter, it's in our Slack again, and please follow up and keep engaging with us.
Awesome. Thanks so much. Bye. All right, switching over now. Damn it. So Crowdcast always has been acting up. I hope it is not crashing right now. Damn it. So Crowdcast actually already crashed once today during the conference, but no one noticed, thankfully. Yeah, like